On the next Earth Science edition of Indiana Expeditions, we'll be investigating Indiana weather. We'll stop in to talk with Steve Bray from the Forecast 8 weather team. We'll spend some time in the clouds, and we'll take a look at some of the effects our climate can have on the planet itself, all in the name of Earth Science.
Try it yourself.
Let's go check it out. Come on.
Indiana Expeditions with Rick Crosslin is made possible through the generous support of the Dr. Laura Hare Charitable Trust, enhancing Indiana's natural environment through preservation and protection of ecologically significant natural areas and promoting environmental education, stewardship, and awareness. The Center for Student Learning, Indiana Department of Education, and Veolia Water, Indianapolis. As the operator of Indianapolis Water, Veolia is dedicated to providing billions of gallons of clean, safe drinking water to nearly 1 million customers in central Indiana every year.
When you talk about weather, you really are talking about water and the water cycle, because weather is influenced by the water that evaporates and goes up into the sky and then comes down. Much like this water going up in the air, there's an electric pump that pushes it up. But you might ask, what pushes the water up in the sky? It's a much larger force. In fact, it's the sun. The sun, heat comes down, heats the water that's in the lakes and streams and even in forests, and it evaporates up into the sky. And then those small droplets of water vapor come together and they condense and they fall back as rain, snow, ice, and other precipitation. In fact, that's the whole cycle, and the power behind the cycle is the sun. Weather. It's not that hard if you learn a little bit of science. Today, I got a weather break. I'm on the top of the One America Tower in downtown Indianapolis. In fact, we're pretty high up. We're actually in the clouds. A cloud is nothing more than water vapor that is condensed into this big body of floating water up in the sky. And when they come together in just the right circumstances, they start to come down. Now, actually, some of those water drops will actually evaporate on their way down, but most of them hit the earth in a form of precipitation.
Water vapor goes up into the sky, condenses into droplets, and falls back down. This process can take on many forms: rain, ice, hail, or even snow. These conditions can be very hazardous. Another aspect of the weather cycle is the air itself. Things can get really interesting when cold air from a cold front meets the warm air in a warm front. Our atmosphere is one big mixture of high and low pressure, hot and cold air, and it's all mixing together. Sometimes it mixes together in just such a way that it starts to build with more and more energy, and we get a thunderstorm out of it. But occasionally, the cycle of warm air and cold air can become extreme and turn into something called a tornado, a very dangerous windstorm. A tornado can have winds rotating at speeds of up to 110 miles an hour. The United States has more tornadoes than any other country in the world. Tornadoes are definitely terrifying, and they cause a lot of damage. But there's another form of extreme weather that causes even more damage: floods. When an area is faced with heavy precipitation, our waterways can become saturated. The result is the most dangerous weather phenomena of all. The thing is, that water will always go where it wants to, and it tends to take things with it, especially when it's off its normal course.
3 kids in here, it looks like. They're pretty much just going with it. They can't control it. Get the rope over, throw it. Get it over. See if they can grab it.
Thanks to first responders, these kids were rescued. They learned a hands-on lesson about the power of flooding.
In our world today, understanding the weather is very important. Weather scientists are always working to better understand and even predict weather conditions. But when faced with extreme weather, the best thing you can do is be prepared.
In Indiana, the weather may change every day, but one thing that doesn't change are scientists like my friend Steve Bray here at the Forecast 8 Weather Center. Steve, we're here to learn about weather today.
Great to see you. Great to see you.
Well, I'm kind of new at this, but it looks like you have quite a bit of tools here, and your job basically is to keep us safe from weather.
Yeah, using the technology that we have, it's very important, obviously, to be safe here in central Indiana, where we do get quite a few storms around, and a lot of those tornadic storms and severe thunderstorms and even winter storms. And we use all the tools that we have to give people as much notice as possible to keep them safe.
A scientist that studies weather is called a meteorologist, and they have their own special instruments.
World War II technology gave us a radar that could pick up where it was raining and how big the raindrops were, and then eventually we got into color and we were able to indicate by color which were the bigger raindrops.
Is that from the Doppler effect?
It is from the Doppler effect. It's like an ambulance that comes by you when you're down the road. You hear the siren, and it sounds different coming towards you than it does going away. So using that technology or that theory, we apply it to radar, and so the frequency of a raindrop that's falling towards you or moving away is different, and so the calculation of that can tell us which way the raindrops are moving. With the ability to do mapping, everything from aerial photography to Landsat imagery and things like that, but just the technology of mapping, you know, everybody's gone to the computer and dialed up Google Maps or some other form of mapping, MapQuest, to show where their house is or something along those lines. Well, with radar, we can plot that radar data on top of those maps and be able to show you on that street-by-street basis where we may be seeing something.
Well, I'd like to see some of your radar in action here.
You bet, you bet.
Show us Viper.
Yeah, this is Wish TV Forecast 8 Viper, and what this is a computer system, display system that takes in radars from around the country, radars from right here in Indiana, satellite pictures, temperatures. We can display it all here. This is an example of that. What we're showing is rainfall that's going on in Illinois and just barely into southern Indiana. And we were talking about the mapping. We can use this to zoom in on these storms, show where it's raining right now. We can actually tilt it, show where the rain is underneath it. We can actually put on the lightning too, which obviously very important in these kinds of storms.
A tool like this is pretty amazing technology when you think of the information and how we almost take it for granted. But this is space age stuff right here.
I've been doing this for a little over 20 years, and it's amazing in that time span what we've come from. The displays that we can do now are what I once dreamed of being able to do. This kind of thing to where, you know, if there's a storm in Indianapolis, I can zoom right down here to Indianapolis. If there's a storm that's out by the airport on the west side, we can zoom down here. We can show our Landsat imagery where we're actually looking at what it looks like on the ground at that point.
I always watch the loop, how the weather kind of comes through here. And for me, it almost lets me be a weatherman. I can see it coming, and I kind of make predictions. Oh, I see what's going on here.
It's very important to be able to show the animation or the time lapse of the radar. Weather, in any kind of weather, satellites, radar, because you can really get a feel for the movement. And that's one of the things that people want to know the most. When is it going to hit my house? And so we can lapse this, and we can show you the motion of the rainfall to show which way it's moving and how it's moving over time.
Okay, so you've showed me some of the tools and the science behind this. Now you have all this information in your head, Steve. How do you get it out to people?
Well, this is where it gets fun, because this is one of the things I like about it a lot, is the ability for us to draw the graphics, put together the presentation of it to where we can show you where that hurricane is going to go, where this lightning storm is, things along those lines. But then we put it on TV, and that's the green screen. You want to try it?
I'd like to try it.
All right, let's give it a go. All right, so Rick, this is the green screen. This is where we do the weather. It's the magic of television, because the TV screen that you see at home is the picture that I see here on the sides, and this green wall is blanked out by anything that has the map. So you only see the map, but it's actually just a big old green wall that I have to point to.
Can I come in?
Yeah, come on, come on. Give it a try. What happened to your head?
Well, I brought my green notebook, so this is something you probably don't want to...
That's exactly right. If I had a green tie the same color as this book, the map would show up there. So that's why we can't wear anything that has the same green color as this wall. Some people think the map is somehow on the wall, or we get used to a point where, let's say, this is Minnesota. But the maps change so much in where we're looking and moving around the maps, but it's not like that. You have to look at those side monitors or the monitor in front of you.
Thanks, Steve. This
You're
has been
welcome.
just awesome, and you've helped us a lot to learn more about weather.
Did you know the Doppler effect is named after Christian Doppler, an Austrian scientist? In 1842, he observed that the frequency of a noisy object changes as the object moves toward or away from you.
Today, I have an alarm clock, and let's see what it sounds like when it's just standing still. However, at the racetrack, those cars are moving around at tremendous speeds. And what does it sound like when an object that is moving makes sound? Let's investigate. When an object makes noise and it's not moving, you get a steady frequency. That same object, if it's moving towards you, it comes towards you and the sound is also compressed, so you hear a higher pitch. As the object moves past you, it's moving farther away and the waves seem to be pulled out at a lower frequency. Well, I'll tell you one thing about Indiana weather. You just wait a while and it will change. This is one of the deepest snows of the whole year, which made a lot of kids happy and a few teachers happy too. But this is a form of precipitation, and it's a very unique form because every little part, every little snowflake is a totally different design. Indiana has a temperate climate. We have everything from snow to rain to heat waves. Our weather changes a lot.
And while that's true, something bigger may be changing as well, our climate. But what is the difference between climate and weather? We caught up with Dr. Niogi, the state climatologist at Purdue University, to find out a little more.
The weather is something that you are experiencing now, and today's weather will become tomorrow's climate. So one way we look at it is we have a period of, say, about 30 years or so that we use as a measure of what is going to be a climate of a region. What you're seeing here is nearly 150 years of observations across the globe. So imagine that every observation that has been made across the globe has been averaged, and you get 1 point for that 1 year. Every black dot you see is an average temperature for that year. And what you're seeing here are a number of lines. This red line is the average trend that we have seen over the last 150 years. So it shows you that, say, in about 150 years back, our temperature on an average was somewhere around 13.5 degrees Celsius. But today, it is on an average 14.4 degrees Celsius. So it is increased by about 1 degree Celsius. In fact, there is a well-known phenomena called as the urban heat island. That means the urban area is warmer than the surrounding non-urban area. Now, when you have larger area becoming warmer, there is a tremendous amount of heat that can be stored in that region. So we in fact now see for places like Indiana, in central Indiana, places like Indianapolis, where if you have snowstorms or winter storms or any thunderstorm moving over Indianapolis region, as it approaches the Indianapolis region, it starts splitting and goes around it. This could all lead to changes in our rainfall. It could all lead to changes in where we have thunderstorms. Now, thunderstorms are dangerous, but at the same time, they are very important because they give us rain that we need.
You know, something like recently as this last summer, it seemed like our storms were bigger. We had lots of rain, in fact, terrible flooding here in Purdue and in southern Indiana. What would your answer be to why we had all of this?
Perhaps this is a harbinger of the things to come if we have climate change. where many scientists believe that things are going to be much more extreme in terms of weather.
Scientists at Purdue are actually working with middle school students to teach them how to collect and evaluate weather data and to look for patterns and changes. Dr. Roy Chowdhury is one of the scientists working on this project, and she is helping the students learn the physics behind weather. She says thermal energy, which is the energy the Earth gets from the sun, could be a factor in climate change.
And if we see changes in climate, let's say we find that, oh, the pattern of average temperature going up is happening over several years, several decades, and then we look for what might be the reason behind it. So, for example, we all know that if we keep our car windows all closed and leave a car outside in the summer, it gets really hot. Now, this is all about thermal energy absorption, transmission, emission, how it goes through the glass, what doesn't go through the glass back out again, what absorbs the energy, what emits the energy back.
Almost all thermal energy comes from the sun, and the energy that is not absorbed by the Earth is radiated back into the atmosphere. But where does that energy go? Some of it goes back into space, but the rest is trapped by greenhouse gases in our atmosphere, which can cause the Earth's atmosphere to heat up. The problem is that human activities are increasing greenhouse gases and possibly causing the Earth's climate to get warmer and warmer. Dr. Roy Chowdhury has showed us that increased greenhouse gases may be affecting one of our most important landscapes, the polar ice caps.
And so here is a satellite image of the Arctic, and I see the white represents what?
The white represents the ice cover.
And so this was a composite data from 1979, is that correct?
Right. So this is the 2000.
Wow,
Look
there's a
at
big
the
difference.
here. See where the ice cover was?
Yes, almost all the way there to
exactly.
Siberia.
NASA estimates that the polar ice caps have been shrinking at a rate of 10% over the past decade. Melting ice caps directly affect our coastline and our sea level and could ultimately affect our climate. From the Earth's geological record, scientists know that the climate has gone through many changes. We may not be able to actually see climate change, but you can see the weather change, and in fact, you can be involved in recording changes in weather. Do it yourself by joining the Community Collaborative Rain, Hail, and Snow Network, or the CORaHS, where you can help scientists by collecting data to put these theories to the test. Check out the website at CORaHS.org.
Being a volunteer CORaHS observer is easy to do. You just go out to your rain gauge, look at the precipitation, point 22, and we report it on the computer. CORaHS is a fun hobby, and it is used by the National Weather Service, by Purdue University, and by other states as well. So you're helping your community by being a CORaHS volunteer observer.
There's lots of places you can learn about the weather. Television, radio, but if you're at Maplewood Elementary, the best place to learn about weather is in Mrs. Hoax Kindergarten class, because they're all about observing weather. Let's check it out.
The kids in Mrs. Hoax Kindergarten class have really been busy this season. They've been observing the weather, and they've been keeping track of what they've seen.
The wind. I believe that everything that I do in our daily program is science. I think I do science in language arts, I do science with math, I do science all day long, because I think one of our focuses in kindergarten is to teach them how to use their 5 senses in everything we do.
As the students use their 5 senses, they're developing valuable science skills.
Now, what can you tell me, Megan, about the clay? What do you remember? What we did, we took 4 objects that were different weights, and we put them on the meter stick. And once again, the students got to use their 5 senses to observe each object, describe it. How did it feel? What do you think? But it's also important for them to realize that when you are doing science experiment, maybe you need it to do more than one time. Because just like tomorrow we might not have wind, so it's going to affect our results. We're going to do the experiment for 5 days. And then we're going to see what conclusion we are going to come with our the data that we've gathered. So they've learned a lot of things about weather. These little kids come to school with maybe limited backgrounds, with limited experience, and I think they're just like a little sponge. They just want to absorb everything. It's a really good feeling. It's a rewarding feeling that you have made a difference in their lives.
Finally, I'm here chasing a storm chaser, but I think I found the right office. Dr. Call?
Yes, hi.
Finally, I've been kind of chasing around here at Ball State University looking for you. Now, I got one question. We're here learning about weather and storms, but you're a professor of geography. What in the world does geography have to do with storm chasing?
That's right. If you're going to chase storms, you got to have a map.
So the way you learn about where the storms are has a lot to do with map reading and maps.
That's right. And here in geography, we're also pretty concerned about how storms affect people. And of course, the whole reason to go storm chasing is so we can learn more about the storms and forecast them better.
Dr. Call teaches college students about meteorology and geography. Storms fascinate him. So when the peak storm season of May and June arrives, he and a group of students head out to the Great Plains in search of scary storms and terrifying tornadoes.
We take about 10 students, we go out there, we forecast the storms, we chase them, and we see how our forecasts work out.
And I guess you use maps almost every day out there.
You bet. We have a whole stack of maps that fit a big box. We have a GPS navigator system, and of course we have real-time radar, which we can hook in with our GPS as well to keep track of where the storms are.
Well, that's a real hands-on experience if you like that kind of storm chasing. Most people are deathly afraid of storms and head for cover, and here you are going out in the plains looking for them.
Yeah, well, you know, with the radar and just a little bit of basic storm knowledge, it's relatively safe. I like to say the biggest threat in storm chasing is the driving. Last year we logged more than 6,000 miles.
I can't believe that Ball State University has a class and their own laboratory for people who want to chase storms. Dr. Call, let's go check it out.
All right.
So, Dr. Call, we're here at the Ball State storm chasing room, I guess. What goes on in here?
Well, this is where a lot of our forecasting takes place, and of course we are an educational institution, so a lot of our students work on their projects here. And when our local Ball State Storm Chasers group goes out chasing, this is their nerve center with the wall map and the two-way radios and the radar.
And so this last summer I see you use these computers and see some of the images from your trip?
Yeah, this is one of our best images from out in western Kansas. That was where we spent most of our summer.
Dr. Call says that before these students can join the expeditions, they take lots of courses to learn about meteorology. He told me they take classes in math and physics, and even classes in broadcasting. Dr. Call was fascinated by weather as a child and spent a lot of time studying it in high school and college. He knew he needed to know more about geography to understand meteorology.
Because so much nowadays we have to think about how people are affected by the weather. Forecasts are getting better every day, but yet still people die from weather disasters.
These days we worry a lot in Indiana about ice storms because they're so dangerous and they disrupt our daily life. Dr. Call explained to me that although our state has always had ice storms, they've really only become a problem in modern times.
It wasn't until we became so reliant on electricity and being able to move around in automobiles and other forms of transportation that ice storms started to have an effect. 100 years ago, ice storms, not too big a deal. So Rick, this is the Indianapolis radar image right now. And actually one thing about radar is that it shoots at different levels. So this is the low level radar image. If you go higher up, you'll see less precipitation because most clouds aren't that tall. But for us when we're storm chasing, this is real useful because if we see rotation high in the cloud and then all the way back down here at low levels. And actually this is useful too, like right here, there's no precipitation falling at low levels, but if you just looked at this higher image, you can see that it's snowing and evaporating for whatever reason before it gets down to the ground there.
Dr. Call explained that because of better forecasting and the use of Doppler radar, Americans across the country now know sooner if a tornado is coming.
Tornado lead time has gone from -2 minutes, meaning the average warning was 2 minutes after the tornado hit the ground, to somewhere around +9 or 10 minutes, meaning you, on average, might get 10 minutes warning before a tornado, which is a lot better than 2 minutes after it's hit.
Yeah, in a severe storm, minutes can save your life.
Yeah, exactly.
So you use a radar to understand the Doppler effect, but how does it really work?
Well, it just sends out a beam of microwave, and things like raindrops, snowflakes, even bugs will reflect that back to the radar. So it's a big dish that just receives that reflected energy back, plops it up on the screen. You can see where it's raining, snowing, or as I say, we can even use radar to detect things like bugs, fronts, and all sorts of other small-scale boundaries.
You have a button on there that tells which schools will be delayed and canceled, because that would be a screen that most kids would like to see, and teachers too.
Yeah, you know, we should look into mapping that out. Yeah, well, that's predicting human behavior, whether or not the superintendent's going to call off classes for the day, and
That's true.
we can't quite model that yet.
We can only hope.
Yeah.
So if I want to be an official storm chaser, this would be the school to come to become one.
That's right. You can take the classes you need and take our storm chasing class too.
What would I need besides you and some instruments? Any other tools I should take along with me?
Well, it'd be great to have a radar in whatever vehicle you're chasing in so you can see exactly where the storm is. You don't want to get hit by the storm. You want to chase it yourself. A map so you can figure out where you're going, or a GPS system. And of course, outflow from storms can be pretty cold, so don't leave without your storm chase sweatshirt.
That's great. He is a geography professor after all, so I expect to get a map, but I'm really pleased to get to know you and to have my official Ball State University storm chase team. Weather and science go hand in hand. Weather is the perfect science project because it involves physics, hydrology, geology, observation, making predictions, and lots of questions. And it's the one type of science where it's okay to have your head up in the clouds. I'm Rick Crosslin. Join me on the next Indiana Expeditions. For more information on Indiana Expeditions and lessons that go with the show, visit indianaexpeditions.org.
Indiana Expeditions with Rick Crosslin is made possible through the generous support of the Dr. Laura Hare Charitable Trust, enhancing Indiana's natural environment through preservation and protection of ecologically significant natural areas and promoting environmental education, stewardship, and awareness. The Center for Student Learning, Indiana Department of Education, and Veolia Water, Indianapolis. As the operator of Indianapolis Water, Veolia is dedicated to providing billions of gallons of clean, safe drinking water to nearly 1 million customers in central Indiana every year.